Until recently, the performance of a prototype integrated circuit device was assessed by means of a probe card, making physical contact at a limited number of points. Now, the high packing densities typical of modern VLSI circuits have rendered this technique obsolete. Today, utilizing an SEM, the integrated circuit can be mounted on a special module for examination, using the recently developed technique of voltage contrast, which measures the electrical potential of the entire surface being scanned and maps this as alternating shades on the screened image. The most obvious application of this technique is in the dynamic design validation of prototype ICs. Here, we see a dynamic memory device in operation as coded information ripples through from top to bottom. With the clock rate speeded up, we can see several trains of coded information following one another through the circuits, producing a concertina-like pattern. However, the only sure way to test a semiconductor device is to run it at full design speed, perhaps at frequencies of several megahertz. In this case, the microscope is strobed at a frequency close to that of the IC, thus enabling the operator to observe the current flow, all the time with it working at full design speed. Don Ramasinghe, British Telecom Research.
This technique enables a test engineer to observe a large circuit operating very quickly. In principle, one can use a probe stage for probing into various circuit nodes. But a scanning electron microscope gives a far clearer idea of the entire circuit operation very, very quickly. More and more semiconductor engineers are using scanning electron microscopes to design and validate their designs using the voltage contrast technique, and therefore in time to come there will be a greater use of the scanning electron microscope for semiconductor work.